Hello student, good morning to all. As you know, this is your physics period. So I am going to take lecture and today's topic, third equation of motion. As you know, in our previous video, I have discussed about first and second equation of motion. Today I will discuss about the third equation of motion. To find third equation of motion, to derive third equation of motion, first of all we have to draw VT graph. This is velocity time graph. To draw velocity time graph, let your x-axis represent time and y-axis represent velocity. If object in rest, then you have to start from this point, but to take some initial value, let your object moving with initial velocity u. So the value of OA represent initial value. Okay, it means OA equal to initial velocity. This is equal to u. If your object moving with a uniform acceleration, start to move with uniform acceleration, then as you know, for uniform acceleration there is a straight line like this, and this is the slope that represent the value of acceleration for your VT graph. That this point is B. When a perpendicular is drawn from point B on x-axis, let this point is C, and another perpendicular is drawn from point B on y-axis. Then the perpendicular drawn on x-axis is represent time of motion. It means T equal to OC, and let this point is T, and this is also equal to PD. Okay, and the value of OD is represent final velocity. It means this is equal to V, and this OD equal to CD. If a perpendicular is drawn from point A on BC, then it intersects BC at point E. This is the perpendicular. Okay, so as you can, this is perpendicular, and the 90-degree angle between x-axis and y-axis, so it is also 90 degree. So it means it is a rectangle. And it is 90 degree, so it is right angle triangle. And this total region lie as a trapezium. Okay, as you know, the distance travel in VT graph is given by the region covered by the object under motion. You can take a small proof for this. As you know, speed is equal to distance upon time. So distance is equal to speed into time. So speed in linear motion, the speed and velocity, the magnitude of speed and velocity will be equal. So you can write this v into t. So distance is equal to velocity into time. If you wanted to find the area of this rectangle, this length OC represent time and this breadth OA represent velocity. So the area is equal to OA into OC. It means V into D. This is the area of rectangle. So the distance is equal to area. It means this is the area. So distance traveled by object for velocity time graph is denoted by area. It means this is equal to area. So I hope you understand. Now we have to prove third equation of motion. So distance equal to area of trapezium OA B C O. OA B C O. As you know, the area of trapezium equal to one upon two the sum of parallel side into distance between parallel sides. So 1 upon 2, this is equal to OA plus CB, and distance between them is OC. Okay, so the value of OA is U and value of CB, and this CB is equal to OD. So you can write OA plus OD and this OC. Okay, so by putting the value of OA U, this OA equal to U, OD is equal to V, and OC equal to T. Okay, and the symbol of distance is S. Now by the first equation of motion. What is the first equation of motion? V is equal to u plus at. So v minus u equal to at. It means v minus u upon a equal to k. And this is equation first and this is equation second. So by putting the value of t from equation second to equation first, putting value of t from second in equation first. So this s equal to 1 upon 2 v plus u. Okay, right? U plus v is equal to v plus u, because as you know the sum of quantities follow convolution law. So v is equal to v minus u upon a. S equal to 1 upon 2 v plus u and v minus u. This is 2k. So 2as equal to, this is the formula a plus b, a minus b. And as you know, a plus b, a minus is equal to b square minus u square. The formula is that a square minus b square is equal to a minus b, a plus b. So b square minus u square is equal to 2as. So v is equal to u square plus 2as. So this is your third equation of motion. So you have to try all these equations of motion, first, second and third, and after that you have to try to solve numerical based on this chapter and this equation of motion. Thank you very much.